So by the very definition, a logarithm can have any base as long as it's positive and not equal to 1. So it can have fractional bases, it can have whole number bases greater than 1. But there are two very, very useful logarithms. The one is base 10 and the other is base e. So we're going to talk about those separately. The common logarithm is base 10. And it's the one that if no base is indicated, like for example, if I just wrote log of x, that would really mean log base 10 of x. This is just a shortcut for this. It's just kind of shorthand for log base 10 of x. So if you do not see a base, it's always understood to be 10, right? Also, the log base 10 is on your calculator. It is the LOG button on the far left-hand side there on the TI 83s and 4s, yeah? That literally says log, yeah. It doesn't have a base on it, but you can only use that when it's base 10. Got it? Okay, so let's look at a couple of other things. And the reason we like base 10 so much is that's what our number system is in. Does that make sense to you guys? Yeah? And our money system is in base 10. And the metric system is really base 10 because you can go from a centimeter to a millimeter, and that's just a base 10 apart. Or you can go from a meter to a kilometer, and those are how many bases apart? Those are basically 3, right? Yeah? Right? 1 meter is
1.001.
wow, 0.001, good, kilometer. All right, so because base 10 logarithms appear so often, you need to become familiar with the following. If you have log base 10 of 1/100th, that's -2, because 10 to the 2 power is 100, and anything to the negative is the reciprocal. So log base 10 of 1/10 is -1. Log base 10 of 1 is what? 10 to what power will give you 1? 0. Log base 10 of 100 is 2, and log base 10 of 1,000 is 3. So those are used very, very frequently over and over again. So those are some of the ones you just need to kind of know right off the top of your head. And so finally, in general, we know that log base 10 of 10 to the x equals x. Now you'll actually get this rule again at some point, but this is pretty important. This is kind of a property of logarithms that's always true. Log base 10 of 10 to the x is equal to just the x, which makes sense if you rewrite it in exponential form, because 10 to the x equals 10 to the x. So that always has to be true. So let's take a look at this equation. Log of x is equal to 0.7482. And we would like to find x to 4 decimal places. So let's start with that equation. Log of x is equal to 0.7482. So because the variable is over there with the log, I can't just type it in my calculator. I can't just type in log of x and it give me the answer. I'm missing the x. So if you're missing something on the side with the log, what do you have to do first? You rewrite it in exponential form. What's the understood base here? 10. So we know that 10 to the 0.7482 power has to equal our missing x. And at this point, you can type that in your calculator. How about you do it for me? Tell me what 10 to the 0.7482 power is. Round it to 4 decimal places.
5.6002.
5.6002. Excellent. I guess actually right here, I should use this symbol. What does that symbol mean?
Approximately.
Approximately. That indicates that I've already rounded. It's not crucial at this point, but if you see one, it does mean that you've already rounded your answer. Any questions about that? Y'all okay with it? Yeah? Okay. That brings us up to natural logs. Natural logs are base E logarithms. They're sometimes called Naperian logarithms, named after this John Napier or Napier. I don't even know how to say his name, honestly. But they're also known as natural logarithms because their base is e. What is e? We talked about it last time. It's the natural base. It equals approximately 2.71828. There's also a natural log button on your calculator. Now, we could write it like this, log base e of x, but because it's used so frequently, they have shorthand for it as well. It's the only log that's not written log. It's sometimes written just ln for natural log or logarithm natural. You know, in other languages, oftentimes the adjective comes after the noun, yes? Yeah. So that's why it's ln and not nl. And these are used almost as frequently as base 10. So if you see an ln, that's understood to be base e. But if you see an log without a base, that's understood to be base 10. Right. So that's the difference in common and natural logarithms. So let's look at some problems involving the natural log. Example 4 says to use a calculator and give your result to 4 decimal places. So we want to take the natural log of 17.32. 17.32. So where's the natural log button on your calculator? It's right
below the log.
It's right below the log. In fact, it's the same button you use to get e to a power, but you don't use the second instead. So let's type this in. The natural log of 17.32. Did you guys get 2.8519?
Yes.
You can. Hence the statement, use a calculator and give the result to 4 decimal places. Any questions about that? Everybody knows how to locate that on their calculator. All right. See if you can figure this one out. The natural log of the common log of 0.05. The natural log of the common log of 0.05.
That not really.
Not
I got
really.
some really random thing. That's
I
why
got
you
an
figure it
answer
out.
plus a imaginary number.
What'd you guys get?
An answer plus an imaginary.
Ooh, what's that mean?
We did it wrong.
Did we do it wrong?
Non-real answer.
So what do I write for that?
Done. I don't know.
Does not exist or
The little circle. is
undefined. Why is it giving that answer?
Because it doesn't.
They cancel out.
Does anybody know? Okay. Well, first, guys, go to your calculator and take it separately, okay? Go type in the log of 0.05. Type that in and tell me what you get. What is the log of 0.05?
Negative 1.3.
Negative 1.3. 010. Yeah, right? Got it? Okay. Then I'm trying to take the natural log of that. But what's the domain for logarithms?
Gotta be
Oh, it
everything
can't
positive.
be below.
Negative.
That'd be greater than
That's-
zero.
Yes, the domain says it has to be greater than 0. So here's something else that you need to know. You cannot take the log of a negative number, ever. You may remember that from Algebra 2. That's why we get it undefined or does not exist. Because you cannot take the log, any log, doesn't matter the base, of a negative number, because that would be outside the domain. So for this composite function right here, we were actually trying to take the natural log of a negative number. The common log worked just fine. You can have a negative number as your answer, but you can't take the log of a negative number. Okay, so for example 5, we want to solve each equation and give the result to 4 decimal places. So our first equation is the natural log of x equals 1.335. To even have a chance of solving that, we need to rewrite it in exponential form. So how does that turn out? What's the base?
E.
E, what's the power?
1.335.
And what does that equal?
X.
Okay. If I didn't let you have a calculator, that's as far as you could go. That would be considered the exact answer. But because I'm asking it around, you have to have a calculator and you have to compute e to the 1.335. So remember, you use second natural log to get there. And we will round that to 4 decimal places. Ooh. Did y'all get 3.800? I actually got 3.799995946. And if I round to the 1, 2, 3, 4th, that bumps it up, right? And it keeps bumping it up until we get to 3.8000. Make sense? Okay. And then how can we check it, you guys? We could take the natural log of
3.8.
that and see if it equals approximately 1.335. So I could plug it back in. Like say the natural log of my answer. Let's see what I get. Natural log of my answer is 1.335. So we can check it. That's good news, right? Okay. And finally, let's talk about part B. On the left side, what's the base? E, right? And so this is technically acting as my power, even though it's another logarithm on the right side. So if I rewrite it as an exponential, I have e to what power?
Log 5.5.
Log of 5.5, which normally would bother me, except for the fact that that's a base 10 log. And if it's base 10, my calculator can handle it. So you literally can just go to your calculator and type in e to the log 5.5. Go give it a try. E to the log 5.5. So if we go to our calculator, we type in e to the log, is it 5.5?
Yes.
5.5. And that gives us 2.0967. 2.0967. Then you could check that by taking the natural log of that answer and comparing it to the log of 5.5 and make sure that they're equal. That's the nice thing about logs is they are numbers, they're numerical, so you can check them a lot better than you can some other things. All right, this is a good spot to stop and take a break.
Good.